We've looked at mass percentage. Now let's talk about volume percentage. It's pretty much the same concept, but with volumes. There are multiple names for volume percentage as well. We call it percent volume or volume over volume percent, and those have some abbreviation symbols as well. For example, the V over V is telling us we have V on the top in our numerator and V on the bottom in our denominator. Both of our units are volumes. So our volume percentage is equal to volume of the solute, that is our component, divided by volume of the solution, that is the whole, and again multiplying by 100 to change from a decimal to a percentage. Here's an example of using volume percentage as part of a calculation. We have a 70% by volume solution of rubbing alcohol. Again, that percent vol is important to tell you that this is not a mass percentage. We're also given the density of pure isopropyl alcohol, which is 0.785 grams per milliliter. Isopropyl alcohol is the main component of rubbing alcohol. We want to find how many grams of isopropyl alcohol are in a 355 milliliter bottle of rubbing alcohol, which contains both isopropyl alcohol and water. Our first step is taking our known quantity, the volume of the solution of rubbing alcohol, and using our percent by volume of rubbing alcohol to find how many milliliters of isopropyl alcohol would be in that bottle. We start with our 355 milliliters of solution. Milliliters of solution has to go on the bottom of our conversion factor, and milliliters of isopropyl alcohol is going to go on the top of our conversion factor. That 70% tells us that 70% of the solution is our component, in this case, the isopropyl alcohol. So out of every 100 milliliters, 70 of those would be the isopropyl alcohol. We can do 355 times 70 divided by 100, and that tells us out of the 355 milliliters of solution, 248.5 of those are the isopropyl alcohol. Then we can use the density of isopropyl alcohol as a conversion factor. So we're going from milliliters of isopropyl alcohol to grams of isopropyl alcohol using the density of isopropyl alcohol. There are 0.785 grams of isopropyl alcohol per 1 milliliter of isopropyl alcohol. We're multiplying our 284.5 milliliters of isopropyl alcohol by our density of 0.785, and that tells us that 195 grams of isopropyl alcohol would be present in that 355 milliliter bottle. Another unit of concentration could be mass volume percentage. This would have mass in the numerator and volume in the denominator. We can abbreviate this as M over V for mass over volume, or W over V for weight over volume. Mass volume percentage is mass of the solute, again our component, our small part, divided by volume of the solution, that's our whole thing, times 100%. If we want to convert between mass percent and mass volume percent, we can use the following equation. Mass over volume percent is equal to density times mass percent, or in other words, W over W percent. Mass volume percent is not a true unit of percentage because the units are not the same on both the top and the bottom. We have mass, which would probably be in grams, and volume, which would probably be in milliliters. Although mass volume percentage is not a true percentage, it's still sometimes used because it is quick and easy to measure in the lab or the clinical setting. Masses are typically given in grams, which you would weigh out on a scale. Volumes are typically given in milliliters, which you could measure in a graduated cylinder. Therefore, you can come out with the mass volume percentage by a quick division problem. In this example, we're trying to convert from the mass percent into mass volume percent. We're given the density of the sulfuric acid solution as 1.7323 grams per milliliter and a mass percent of 80%. We can just plug in our values. are 1.7323 grams per milliliter for density and the 80% for mass percentage. That tells us our mass volume percentage is 138.58%. If you think about it, that percentage is pretty weird. How do we have more than 100%? Again, it's because mass volume percent is not a true percentage. In the chemistry lab, we don't like to use this one very much, but if you go into a medical field, you may encounter this much more frequently.